Hello, my name is Jared Skeens and welcome to the Zoom room. Today in our lesson we want to cover Pure Maths 1, Quadratics, Part 5, Sketching. Now, sketching, you might say, is sketching and graphing the same thing? We often use those words interchangeably, sketching, graphing, graphing, sketching. But there is a little bit of a nuance difference. Usually when you want to graph something, it needs to be more technically accurate. And so you're really careful to make sure that every part of the graph is accurately represented. In a sketch, all you're trying to do is capture the main graph characteristics, maybe a key point or two, the key points, and the relative position of the graph, but not every aspect needs to be technically correct. So in a sketch, it's often used, especially in high school math, for more of a visual reference and can be used for interpretive properties. So you want to be able to do it quickly. It shouldn't be a time-consuming event. So what I want to do is help you to be able to quickly sketch quadratic graphs. Okay, so in a quadratic graph, which is a parabola, and it's a curve. So with a curve, what you want to produce is what I call 3 points of reference. Now, depending on the type of curve, for example, if you have an exponential curve, exponential curves have a horizontal asymptote. So the horizontal asymptote can actually be one of your 3 points of reference, and then you would need 2 plotted points. In a reciprocal function, which goes like this and like this, where you have 2 curves, you also have 2 asymptotes. So the 2 asymptotes, a horizontal one and a vertical one, can act as 2 points of reference, and then you need 1 plotted point. So 1 plotted point on this side and 1 plotted point on that side, and you have your 3 points of reference. With quadratic graphs, we don't have any asymptotes. So we need 3 points, but we don't want just 3 random points. We want 3 key points of reference that gives us a good sketch that we can do quickly and gives us all the interpretive information that we need. It captures the main graph characteristic, which is generally the, where the curve is at. So a lot of teachers, especially on IGCSE level, might have taught you to make an XY chart. And so they'll make a little X and Y, and they'll have you just plot a bunch of numbers. Please don't do that. And I'll give you 3 reasons why. Reason number 1, it's time consuming and inefficient. I've seen some charts go from -5 all the way to +5, and you're graphing like 10 different points, sitting there on a calculator, plugging in number after number and coming up with all the points, plotting them on the graph and connecting the dots. So 1, not time efficient. 2, you're not guaranteed that you'll capture the main graph characteristic by randomly selecting numbers. And the more numbers you select, the more time consuming it becomes. The less numbers you select, the greater the chance that you miss the graph characteristic. Also, you can't just connect the dots. Now, connecting the dots will work for quadratics, but there are some graphs, for example, your reciprocal graphs, you can't just connect the dots. That's not how graphing works. The third reason why I don't want you to use that method is because it is a low-level critical thinking. It doesn't help you as a student understand graph characteristics and things that you should be looking for. You're just blindly plotting values and you don't really know why or what it gives you. So I want you to be efficient. I want you to make sure you capture the main graph characteristic, and I want you to understand what you're doing, okay? So with quadratic graphing is going to depend on the form of the equation that you have, okay? And we're going to go through and we're going to look at 3 different forms that correspond to things that we have already worked with. In part 1, we worked with factoring. That's the first form that we're going to look at. Part 2, we looked at completing the square. So we're going to look at completing the square and sketching. And in the third part, we dealt with the quadratic formula and the magic potion method. And so we're going to look at that as our third sketch. All of them sketch quadratics, but just the format of the equation is different. Okay, so let's get started. And we've talked about defining sketching. We've talked about 3 points of reference. We're going to do it from our already developed quadratic things that we've learned. So again, in part 1, we learned factoring. Well, when you factor an equation like this with y equals the equation, this is called intercept form. And we'll talk about why it's called intercept form in a minute. But the method that you're using to get there is factoring, okay? So let's take our quadratic equation. Now remember back in part 1, we were focused on solving an equation. So you would see something like x squared plus 4x minus 12 equals 0, and then we would factor it, and then we would set the factors equal to 0 and solve. Remember our 3 levels: equation, factors, and roots or solutions. So we would start at the equation level, we would factor, and then we would solve. Well, in a graph where you have an x and y axis, it means you have 2 variables, not just one. When we have our equations, normally we just have the x, not the y. So when we move from the 1 variable equation into the 2 variable equation, now we're looking at our xy axis graph plot thing that we're working with. And the x-axis is where the y equals 0. In other words, here's y equals 1, y equals 2, y equals 3, y equals -1, -2, -3. Right here at the x-axis is the y equals 0 line. So if we just get rid of our equals 0 and put y equals at the beginning, it's basically the same thing. So when we are factoring and changing it into intercept form, we're in essence finding where the y equals 0, or in other words, we're finding where our graph crosses or intercepts the x-axis, okay? So we're using the factoring method. So we come here, which gives us a chance to review our factoring. Factors of 12, 1 and 12, 2 and 6, 3 and 4, and they have to subtract to give you 4. Well, that's going to be the 2 and 6. 6 minus 2 gives us 4. So that means we have x minus 2 times x plus 6. And we can double check. X times x is x squared. -2 times 6 is -12. A positive 6x minus 2x is 4x. So we know that we did it correctly. Now, notice up here I put an A. That's just in case. Remember when we talked about factoring, I said the first question you should ask is there something common to all the terms? Monomial factoring, you should always check that first. Well, if there was something common to all the terms, you could factor it to the front. That's what the A represents. In this case, there's nothing common to all the terms, so we don't have that A. What we're more interested in is this P and Q. We're interested in the intercepts. So once we got this, it's just like your Y equals 0 is what we're really solving for. So you can still take these and set each one your zero product rule. X minus 2 equals 0, X equals 2, X plus 6 equals 0, X equals negative 6. Now these are 2 of your 3 points of reference. These are 2 key points, not just any random point. We factored so that we could get intercept form so that we can have 2 of our 3 points of reference. They're 2 important points because it's where it crosses the y-axis. So here we have at 2, 1, 2, and here we have at negative 6, 1, 2, 3, 4, 5, 6. Okay, so 2 and negative 6. Now that's already, here's our P, here's our Q, doesn't really matter which one you call what. 2 of our 3 points of reference. Now we only need the third point. And in any type of quadratic, the most key point is the vertex. It's where the curve changes from going down to going up, or if it's facing down, going up to going down. Now we know this one is facing up because the x squared is positive. If the x squared were negative, it would be going down. The x squared positive, it's facing up. So we know it's facing up, and it goes through these two. We need to find the vertex. Remember, the vertex is the midpoint, or the x-coordinate of the vertex is on your axis of symmetry. So all we have to do to find the midpoint, add them together. So we get negative 4 over 2, which is negative 2. Negative 2 is going to be our axis of symmetry. Notice it's 4 away. This negative 2 is 4 units away from positive 2, and it's also 4 units away from negative 6. Okay, so this is our Q value here at 2, and this is our P value here at negative 6. So the P and Q being our roots of our intercept form. So now that we know that the X value is, or that the vertex is somewhere on this axis of symmetry, now all we have to do is plug it back in and figure out what the Y value is. So I'll put it over here, Y equals, and you could do it in either place, by the way. So you could do it up here where you get negative 2 squared plus 4 times negative 2 minus 12. Get 4 minus 8 minus 12. That's a negative 4 minus 12, which is negative 16. You could also put it in here. Negative 2 minus negative 2 is a negative 4. Negative 2 plus 6 is a positive 4. Negative 4 times positive 4 also equals negative 16. So you have 2 places that you can plug that number in. You can plug it into the original equation, or you could plug it into the factors, the factored form, and either way you'll come up with the correct value. So the vertex is located at negative 2, negative 16. Now the nice thing about a sketch is it's not really about accuracy. You don't necessarily have to put these 1 per 1 tick marks. You know, you don't really have to even have these if you don't want. It's not about technical accuracy. It's about the general shape of the graph. So we can just come down here and we can put our negative 16 down here without really counting, and here is our vertex. So this is going to come up through here, and this is also going to come up through here. It doesn't have to be pretty. Again, you want one, time efficient. These Cambridge tests, the time goes by quickly, and sketching is actually not a main question type. Once in a while, either in quadratics or functions, or even in a future unit that we learn, it might just ask you for a sketch. And there might be a couple of things involved. You still could have lines, you could have a quadratic, you could have some other function like exponential or some other. So the more graph types that you learn and understand in your head, the more that you'll be able to do in those little, hidden questions, not the main question types, but occasionally in like the part B or the part I, it says sketch. So we don't want you thrown off guard and say, I don't know how to sketch. So the more that you learn graph types, the better that you will develop your graphing skills or sketching skills. Sometimes you might also want to draw a quick sketch, not because it asks for it, but for your own visual aid, and so that you can see some interpretive things that are beneficial for your understanding of the question. Remember, the algebra and the graph correspond. It's not algebra only or graph only. They both correlate. And the more that you can correlate in your mind between the algebra and the graph, the better your understanding will be. So sometimes a quick sketch can help you with interpretive things that help on the algebraic side that maybe you can't see just in the algebra. So here is the intercept form based on factoring. It automatically gives you 2 of the 3 points of reference, which are very important points because it's on the x-axis. Very easy to take the midpoint to find your x-axis value for your vertex. Then you just plug it in either to the equation or to the factors to find the y value. You make a quick sketch. You don't need to do 1 per 1 and make a perfect, don't get out your ruler and try to make a perfect graph. It's time efficiency with main graph characteristics. That's the goal. You want to do it quickly and have it done, okay? So this is the first form, and I'll set it up really quickly for the second form. Okay, here we go with our second form. Our second form is called the vertex form. Obviously, from the vertex form, we get the vertex, which, like I said before, is the most key point on a quadratic graph. And this form comes from completing the square, which we discussed in part 2 of our series. And you can see that this format was your medium level out of your 3 levels of complete the square format. Both that first easy level that didn't have the A and that second medium level, which has the A factored to the front, both of those are very graph friendly. That third, more complicated level where the A is put inside, we don't need that for the graph characteristic. So all you need is, depending on whether you have something to factor out or not, this can be a 1 or the A factored out. This is the form that you need. Now, I'm not going to start you from the original y equals ax squared plus bx plus c form. You already know the complete the square process. We're not here focusing on how to complete the square. What we're looking at is the form after we've completed the square, or maybe your question even starts with it already in the complete the square form. We're focused on the graph characteristics. How do we get our 3 points of reference? So in our intercept form, we had 2 intercepts in the vertex. Now with our vertex form, we're starting with the vertex. We're starting with 1 point of reference, and we have to come up with 2 more. Okay, so notice first of all that to interpret the complete the square form, your vertex is the opposite of this H. I used H and K instead of the P and Q. I'm used to using H and K for translation values. which I'll explain in a minute. Notice that it's the opposite sign of the H and the same sign for the K. Now that can be a little confusing. Why do you change one sign but not the other? Well, originally, if you look at how this, say, develops from another point of view, some curriculum even do that this K originally belonged over here. You see, this H value is how your parabola shifts left and right. Your normal parabola, or your parent function parabola, is just y equals x squared. That's the most basic quadratic graph, which has an origin at 0, and so your graph goes something like this at the origin. Well, your parabola doesn't always stay at the origin. It moves. So this is actually used for translating. That means shifting your graph left and right, up and down. This H value is your horizontal shift, and the K value is your vertical shift. So because it's the horizontal shift, the H, that's why it's connected to the X, which is your x-axis. The K originally is your vertical shift, meaning it's really attached to the Y value. Now, the reason why it's moved over is because most of your graphing equations make Y the subject. It's solved for Y. Your linear graph, Y equals mx plus c. Your quadratic, Y equals ax squared plus bx plus c. Most of your function notation and graphs start with f of x equals or y equals, and then everything else is on the other side. So some curriculum will actually show this, but some don't even show that because we prefer to have the y as the subject. So I'll leave that just for now. So if our vertex is, say, moved to a different location, so here's the x shift, that means here is your new x value. Well, to get it back to the origin, you need to subtract something. Here is h length. So to get back to the origin, you have to subtract h. To get here back to the origin, this is your y value. If this is your k, then you have to subtract k to get back to the origin. That's why this is subtract and this is subtract. It tells you how to get from where your vertex is back to the origin horizontally and vertically. So that's where the negative comes from. But then again, because we want y to be the subject, well, the k got added to the other side so that y can be the subject. So since we have already changed the value of the k, we don't need to change it again. We only need to change the x value. So I'll explain it one more time when we get this graph done, just so that you can get the picture. But remember, the subtraction is how do you get back to the origin or the original parent function. So let me get rid of that really quick and restore this back to what we want. Get rid of that. So this is our, parent function graph. Now, here is an example quadratic equation that you might be asked to sketch. And if you notice, there's the A in the front. The A does not affect the vertex. What the A affects is how wide or narrow your parabola, stretches out. So you don't really have to worry about it. It's not something that you should really concern yourself with. All you need to know is that number either makes it wider or narrower depending on whether it's a whole number or a fraction. So you don't really need to worry about it. What you want to focus on are your 3 points of reference. And right away, we have one of those points just by looking at the form. It's vertex form. So remember, we change the h and we keep the k value. We change the one that's attached to the x. It tells us, that only tells us how to get back to the origin. We're at 2, so if you subtract 2, you get back to the origin. This one has already been moved over. It was plus 3, so we subtracted over. It means we're at negative 3, and you would have to add 3 to get it back to the origin. So this is at 1, 2, and 1, 2, 3. This is where our new vertex is. So notice you would have to subtract 2 to get back to your origin spot. And if this were moved to the other side where it was actually attached to the y, it would be a plus 3. You would have to add 3 to get back to the origin. So that's the meaning of why we change one sign but not the other. So we have one of our 3 points of reference. Now we need 2 more. Well, we don't want to go through all the work of multiplying this all out and then factoring to get the intercepts. So what we want to do is we want to plot 2 points. Now I thought you said at the beginning, don't just plot points. Well, we don't want to just plot random points. We want to, and we don't want to plot many points. We might have to plot a point, but we want to plot an intelligent point. You say, well, what's an intelligent point? Well, look, here is our axis of symmetry. Okay, I'm going to get rid of our parent function. We don't really need him anymore. Okay, there's the parent function. And this is our axis of symmetry, goes through the vertex. So our vertex here is the main point. And we know because this is positive, the A is positive, that it's going to face upward. So you don't want to go too far away from your axis of symmetry. If you go far from your axis of symmetry, your value on the y-axis is going to be way up here. Okay? You want to stay relatively close to your axis of symmetry. And a really easy number to use, 0. As long as your vertex is not on the y-axis and the 0 is not far away from your axis of symmetry, then that's an easy number to use. If your vertex happens to be on the axis of symmetry, then pick like 2 or -2. Pick a number that's close to it. Sometimes you don't want to be too close because then your 3 points are like really close together. So maybe 2 units away on either side. It's up to you. But if that 0 is close, zeros are easy to work with. We come back here and we put in a 0. Okay, so what we're doing is we're going to create ourselves a very small XY table of only one value, not a big long one. So if x is 0, we want to find our y. So if this is 0, we have a -2 squared. Well, a -2 squared is 4. Times 2 is 8. Minus 3 is 5. And maybe you didn't follow mentally what I just did. So what I just did was I plugged in a 0. This gives you -2 squared. This gives you 4. This gives you 8. And that gives you 5. Okay, I just did it mentally. If you need to work it out, you can. If you can do it mentally, just follow your orders of operations. So parentheses first, 0 minus 2 is -2. Then exponents, -2 squared is 4. Then multiplication times 2 is 8. Then subtraction, 8 minus 3 is 5. 0, 5. We only plotted one important point. an intelligent point. So we are at 0, 5. 1, 2, 3, 4, 5. It's not too high off our graph as if we were out here or out here. So that is one of our points. Now, we've only plotted one point. I'm going to erase this now. I'll put it back over here. Our point was 0, 5. And what we're going to do for the third point is use our property of symmetry. That means that the distance between here and our axis of symmetry is the same as the other side. So if we're 2 units away on this side, then that means we're also 2 units away on that side. So we used our vertex, which was already in the form. We picked an intelligent point for plotting. Then we use our property of symmetry to find the third point. So our graph goes through like this, and our graph goes through that. Just make sure you don't make a V down here. It does need to be a curve. Curve means there's no pointy parts. Don't make any pointy parts on your graph, because that is kind of a, the people looking at it won't like that. It is a curve, so do try to make it a little curvy down there and avoid that V shape, okay? So again, it doesn't have to be perfect. Do avoid the V. You got 3 points. You have the most important, and you have 2 others relatively quickly. Once you get used to what you're looking for in your 3 points, you can actually do this quite quickly. Took us a little longer because I'm explaining it to you. But once you get the hang of it, you can actually sketch a quadratic graph really quickly. So I'm going to set up for our third and final form, and then you will have all 3 of your sketch forms necessary to be successful at sketching a quadratic. Okay, here's our third and final form for quadratics. And just like factoring we covered in part 1, complete the square we covered in part 2. In part 3, we covered the quadratic formula and the magic potion. Both of them, basically do the same thing. So when we look at that, those come off of the standard form. The standard form is really kind of just general. It might even be called the general form, sometimes general form or standard form. Y equals ax squared plus bx plus c. And unfortunately, it doesn't give us much of anything as far as graph interpretation. So we're going to have to work a little bit for our 3 points of reference, because this is the least helpful form. But there is a starting point that we have. And in both of these, we were able to see the midpoint, that is the x coordinate of the vertex. So it doesn't give us the entire vertex like the complete the square form, the vertex form, but it at least gives us the x coordinate of the vertex. So that's our starting point. Besides the vertex is the most important point on the quadratic graph. So remember, from the quadratic formula, there's the negative b over 2a in the front part of the formula. Also, with the magic potion, now with the magic potion, I decided to divide the a through so that we didn't have to deal with it, and we still had negative b over 2. If you kept the a, you would also have negative b over 2a. So in both of those, they provide you that x coordinate of the vertex. So here again is an example of a quadratic that we might want to graph. Now, I kept the numbers simple for illustrating our 3 points of reference. You can get more complicated where you end up with fractions and things like that. So it doesn't always come out with nice numbers, but you can use your calculator to help you. I've used nice numbers so that you can learn how to find the 3 points of reference quickly from each of our 3 graph types, or 3 forms of the equation. So when we look at this, we want to identify the vertex, the x coordinate of the vertex. it's the opposite of b, so that's a positive 2 instead of a negative 2, divided by 2a. Well, our a here is an understood 1, so all we need to do is divide it by the 2. 2 times 1 is still 2. So divide it by 2, and this is the x-coordinate, means our vertex, or the x-coordinate of our vertex, is at 1. So at 1 is our x-coordinate, and that's also the axis of symmetry. Remember, your vertex is on the axis of symmetry to where your quadratic folds in half for it. So somewhere on here is our vertex. So to find it, all that we need to do is plug in our 1. Maybe I should have put that up here. We ended up with a vertex of positive 2 divided by 2, and we're going to get a 1, and we're waiting for the y value. So if we plug in y equals 1 squared minus 2 times 1 minus 8, we can find the y value, 1 minus 2 minus 8. So this is a negative 1 minus 8, which is a negative 9. So just careful with your order of operations. Do your math step by step. You know, you can go quickly, but also be careful not to make mistakes. So down here, again, we're not interested in 1 per 1, making perfect little tick marks for a graph. Just down here, we're going to put negative 9. Okay, it's a sketch, it's not perfect. And here is our vertex. And now we need 2 other points of reference. So again, we want to pick an intelligent point for plotting. And we could use the 0. And if you notice, if we use the 0, it makes it really easy to calculate. 0, 0, and you have negative 8. So you could use that if you want. However, when you're only 1 unit away from your axis of symmetry, it kind of makes your points. You'd get a point here at negative 8. You reflect it over your axis of symmetry. All 3 of your points are really close together. So in this case, I'm going to move back to negative 1, okay? 0 is easy, but it kind of puts our points a little close together. So I'm going to pick, for my intelligent point, I'm going to pick negative 1. It's 2 units away. Or we could even use 3. If you don't like using a negative number, if you feel more comfortable with a positive number, then let's go 2 units this way and use 3. That's an easy number to work with. So if we work with this, we get y equals 3 squared minus 2 times 3 minus 8. This isn't bad. 9 minus 6 minus 8. 9 minus 6 is 3 minus 8 is a negative 5. So a negative 5, that's almost halfway, just a little closer to the negative 9. And we went back to not at 0, but we went to negative 1. So negative 1 and negative 5. So it spreads the points out a little bit, makes your graph a little bit more accurate than if your points are close together. So that's our second point, 3, negative 5. Now, again, we use our symmetry property. This is 2 units away from our axis of symmetry. Oh, wait, sorry. I said negative 1, but actually I meant 3. 3, negative 5, we switched. I forgot we switched. But if you notice, if you use negative 1, you're going to get negative 5. Why? Because it's symmetrical. So we got 3, negative 5. This is a little close. Again, it doesn't have to be perfect, but we do want it to look nice. So we have 3, negative 5, which is down here. Okay? Sometimes I'm a little too careful. You don't really have to be too careful. So we have 3, negative 5, and we use our axis of symmetry of over 2. So we go 2 this way and we get to our -1. So really it didn't matter whether you use -1 or 3 because they're both the same units away from the axis of symmetry. You're going to get the same y value. That's why the graph is symmetrical. Then again, try not to get your V shape at the bottom. Make sure it's curving up like this. And when it curves up this way, you get like this. And if you notice where it's crossing the x-axis, this actually can factor. Factors of 8, 1, and 8, 2, and 4 that subtract to give you -2. Well, that's going to be 2 minus 4 gives you a -2. Okay, so if this were x plus 2 and x minus 4, you get x equals -2. What do you know? We're right at that -2 spot, and x equals +4. And what do you know? We're right at about that +4 spot. So you could factor it to get your two intercepts. So you would have gotten 4 and -2. That's always an option to go from standard form into your intercept form, or do something like this where you plot one point and use the symmetry to find the other point. But the vertex is what's important, and you can find the x-coordinate of your vertex from the standard form, and we get that from either one of these two, quadratic formula or magic potion. Plug it in to find the y value. That's your starting point, whether you want to factor it quickly to get your two intercepts, or whether you just want to plot an intelligent point and reflect it over your axis of symmetry. You have several options, but here you're getting to understand the graph. It's helping you with factoring, completing the square, the quadratic formula, or the magic potion, whichever one you prefer. You're starting to understand the graph type. That's what's going to give you confidence in sketching graphs in the future. I see a lot of students who are only taught to do XY charts. They just fill in a bunch of numbers and connect the dots. They get into the future sketching, and all of a sudden they lack confidence because they don't really understand what's going on in the algebraic relationship to the graph type. And you should learn the formulas as you go. Y equals mx plus c. You got slope and y-intercept. You don't need to make an XY chart. Here we have 3 different forms we've worked through. Find your 3 points of reference. You've got your graph. That is the most important thing. It doesn't have to be super detailed. Okay, so I hope that you develop this learning these 3 points of reference and learning how to find your quadratic graph from these 3 different forms, and it will give you confidence that you will need in the future anytime you're asked to sketch, or anytime you just want to sketch, to give you a visual aid in interpreting what's going on or how it correlates with the algebra. So here we were able to correlate with the intercept form, and it makes sense. And that's when math can be fun. Thank you for joining me in the Zoom room, and I will see you again next time.